My name is Rosario Nicole V, a student from Zamboanga Peninsula Polytechnic State University under the Department of College of Teacher Education, taking the Bachelor of Technical Vocational Teacher Education major in Heating, Ventilating, and Air Conditioning Refrigeration Technologies. This time, I will be discussing to you about the bus air conditioning. So a bus air conditioning is a system designed to maintain a comfortable temperature and humidity level inside the passenger cabin, regardless of the weather outside. Because buses carry many passengers in a confined space. Efficient cooling, ventilation, and air purification are crucial. So a bus needs an air conditioning because for the passenger to feel more comfortable when traveling. Kahit malapit lang yung pupuntahan mo, you want to take the bus, of course, you will choose the bus na may air conditioning for you to feel more comfortable. Lalo na ngayon, yung weather outside are so very hot. We're all experiencing a hot weather outside. So, of course, mas pipiliin mo yung bus na may air conditioning compare sa bus na mainit sa loob. So, the purpose of the bus air conditioning is to cool, dehumidify, circulate fresh air, and maintain comfort for both passenger and driver during long trips or even a short trip lang. So, uh, even you, I know, you want a bus that have a comfortable temperature inside when traveling long or short trips, right? So let's go further with this.
Compressor, one of the most important components in a bus air conditioning system. The compressor job is to suck in low pressure vapor refrigerant from the evaporator and compresses it into high pressure, high temperature vapor. In a simple terms, the compressor acts as the heart of the air conditioning system, pumping refrigerant through the entire cycle. Overall, the compressor plays a vital role in keeping bus passenger comfortable during travel. Electromagnetic clutch are key components in the bus air conditioning system that controls when the compressor operates. The electromagnetic clutch connects and disconnects the compressor from the engine drive boat, effectively switching the compressor on and off as needed. In a simpler terms, the electromagnetic clutch acts as a smart switch for the compressor. Condenser, an essential part of the bus air conditioning system that help release heat from the refrigerant. The condenser role is to cool this vapor refrigerant by allowing heat to escape into the surroundings air, often with the help of the cooling fan. As the refrigerant processes heat, it changes from a vapor into a liquid, making it ready to move on the next stage for the cooling cycle. The condenser is usually installed on the roof or at the rear to maximize airflow and cool efficiency. Refrigerant receiver, an important component of the bus air conditioning system that acts as a storage reservoir for the refrigerant. After the refrigerant is condensed into high-pressure liquid in the condenser, it flows into the receiver, where it temporarily stored before being sent to the expansion valve. The refrigerant receiver ensures that the system always has a steady and adequate supply of refrigerant even when operating conditions change, such as during startup, defrosting, or varying cooling demands inside the bus. filter dryer, a small but vital part of the bus air conditioning system that help keep the refrigerant clean and dry. Its main job is to remove moisture and impurities from the refrigerant before it continues circulating through the system. In simpler terms, the filter dryer acts like a protective shield for the bus air conditioning system. It keeps everything running clean and stable, extending the lifespan of important components like the compressor and expansion valve. Solenoid valve, a crucial control component in the bus air conditioning system. Its main function is to regulate or stop the flow of refrigerant going to the evaporator by controlling when the compressor is turned on or off. When the system doesn't need cooling, such as when the desired cabin temperature is reached, the solenoid valve closes, preventing refrigerant from flowing into the evaporator. This helps conserve energy, protect the compressor from unnecessary wear, and maintain a stable temperature inside the bus. In a simpler terms, the solenoid valve acts as a automatic gatekeeper for the refrigerant flow. Expansion valve, a vital component of the bus air conditioning system that carefully controls the amount of refrigerant entering the evaporator. Its main job is to regulate refrigerant flow and pressure, allowing only the right amount of refrigerant pass through so that it can fully evaporate inside the evaporator. As the high-pressure liquid refrigerant passes through the valve, it rapidly expands and cools down, turning into a low-pressure, cold mist that absorbs heat from the air inside the bus. In a simpler terms, the expansion valve acts as the gateway to cooling. It ensures that the evaporator gets just enough refrigerant to achieve maximum cooling efficiency without freezing up or wasting energy. Evaporator, one of the most important components of the bus air conditioning system. Inside the evaporator, the liquid refrigerant is sprayed and evaporates, absorbing heat from the surroundings air. As warm air from the bus cabin passes over the evaporator cold vents, the refrigerant absorbs the heat and transforms into a gas. This process cools the air, which is then blown back in the passenger area through the ventilation system, creating a refreshing and comfortable atmosphere inside the bus. In a simpler terms, the evaporator acts as the cooling core of the air conditioning system. An important part of a bus air conditioning system, the fans. In this system, the fans plays a crucial role in maintaining a comfortable temperature inside the bus. They work by drawing in the cool air produced by the evaporator, which is the component responsible for absorbing heat from the air. Once the air passes through the evaporator and becomes cool, and the fans blow it into the bus interior, distributing the chilled air evenly throughout the passenger area. Without these fans, the cool air would remain trapped around the evaporator, making the air conditioning system inefficient. By continuously circulating the air, the fans ensure that passengers enjoy consistent cooling even during long trips or in a hot weather. I have here the different types of bus air conditioning. Engine-driven air conditioning, powered by the bus engine via belt, common in standard buses, simple but can increase fuel consumption. Electric air conditioning or e-bus air conditioning, powered by electrically from the bus electrical system or batteries, used in electric or hybrid buses, more energy efficient and eco-friendly. Rooftop unit, the most common configuration. All components except the compressor are mounted on the roof, save space and simplifies maintenance. Split system components like evaporator and condenser are separated, often used in double-decker or larger couches. Here's a safety instruction if you're going to install an air conditioning in a bus. Put on industrial mask, gloves, safety belt, and hat. Do not put on items listed in a row X. When operated on a bus rooftop, do use safety rope and ensure its safety.